don't know about you, but I'm eager to stay on top.
He said,
Yeah.
girl in my group.
That's what I'm saying. Actually get started. What?
Is this, did you have this?
Well, I read this. Yeah, I was next thing you know, 4 weeks is gonna go by.
I mean, you got let's see all of it.
So it's my anti-procrastination process.
Where else? Where else? They have
I'm not trying to come down. I just want to. Oh, my friend.
Hello, everyone.
Wait. No.
Somehow.
They have two balls.
No, I get it. That's exciting. How long are you gonna be there for? So like, sounds like you're like.
I enjoyed my time this weekend, so it's been 5 years.
It's like 20 something degrees this morning, and I just doesn't get someone getting
Practice.
I know, because there was no one else supposed to be doing yesterday.
Yeah, I did.
I think there was one yesterday and then the one before that. And then
I didn't check the sign.
so I was gonna do it Friday and just
And
did.
you were cool.
Okay, so sorry, last Thursday, department told me that maybe there is the class of other people here, so we cannot have the class on Thursday, last Thursday. So we are well behind our schedule, so I need to teach a bit faster to. Okay, we continue our discussion. We continue our discussion on fluid static pressure. If you remember, 2 sessions ago I drive for you that pressure only change in the vertical direction, not in the horizontal direction. On the same horizontal line, the pressure is the same. So we discussed this, and last session, last Tuesday, I drive for you this equation. The pressure change depend on the gamma. Gamma is a specific gravity, rho g, multiplied by altitude. So gamma z is the pressure change. So question, what is the relation between pressure of point A and B? The same. Why they are the same? The same height from here. Because the weight of the water above A and B is the same. Pressure in cap A, greater or smaller than pressure in small a?
Greater,
Greater. Why?
because it's got more water above it.
Yeah, there are more water above it. Okay, question. Pressure in D, how you compare pressure in D with pressure in C? C, all the above is water, a little mercury, some water. Which one is higher? You?
The specific weight of.
Yeah, because gamma of mercury is higher. So even though it is a small amount of H, the gamma of mercury is very high. So you should be very careful. I give you the homework 2, and today I will give you homework 3 based on force on surfaces. So, and then we consider the pressure manometer. We discussed this. The altitude of this mercury is P ambient over gamma mercury. We discussed this. And then we discussed pressure in gases, application of manometry. I solved you an example. And then we start for today class topic, which is very interesting and important about the force over a plane surface. Consider you have a plane surface at the middle of the water. It is like a dam. You have a dam, it has a lid. It is a lid of the dam. So when you open the lid, the water goes out to the pipe, to the river, to everywhere. But now the surface, the lid is closed. And we are engineer, we are mechanical engineer. Our boss told us how strong this lid should be. How much forces are over this lid. So today, we consider 2 types of lid, the inclined surface lid and the curved surface lid. So the aim of today, goal, pressure, force on plane and curved surfaces. This is some topic that requires much of your attention. It is very related to a static course. Okay? So if you understand well the static course, that is good. So we have this inclined surface with the angle theta. It is the free surface. First, I start plane surface. This is angle theta. This is the free surface. And there are 2 important points about this. I don't go to the derivation of the relation because we don't have time. The force. The pressure force over this surface, F pressure over this surface, is equal P, center of gravity multiplied by area. CG is center of gravity. If it is a uniform, question, if this chalk has a uniform weight distribution, where is the center of gravity of this chalk? At the middle. So, center of gravity, we assume this plane surface has a uniform mass distribution. So, we should, it is CG. We should find pressure at point CG. Okay? So for you, it is important to find pressure at CG. You find pressure at center of gravity and apply the pressure, multiply pressure by the area of the surface. But one point. This force is computed as pressure at the center of gravity of the geometry multiplied by area. But the point of action of this force is center of pressure. Center of pressure is not necessarily the center of gravity. So this force acts here. Center of pressure. Did you have the definition of center of pressure in your static? Do you know the definition of center of pressure? Yeah.
Isn't central pressure just like the pressure in the middle or center of like some like object or something?
No, 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 no.
Oh, okay, that's just from what I understand.
No, no. Center of pressure.
Sorry, it's
One question. You have this, let me write here. You have this surface. Okay? You have this surface. Pressure is a distributed load. For example, can anyone justify why my arrows become larger when I go downward? Yeah?
Because you're going deeper into the water.
Yeah, I go deeper in the water, there are more weight of water. This is the pressure force over it. Okay? This is the pressure distribution. Pressure distribution over surface. Pressure is a distributed load. Did you have a course in static? In static, sometimes you have this one. It is a point force. In static, sometimes you have a point force, sometimes you have a distributed load. What did you do with distributed load in static? If I give you this question in static, what did you do with distributed load? Do you remember? Yeah?
You simplify it as a point force.
And where I apply this point force for this one?
For that one, it would be 2/3 of the way to the right.
Yeah, 2/3 from left, I think.
Yeah. Or yeah.
Yeah,
Left.
2/3 from
To the
left.
right.
So, when you have this distributed load, it is equivalent I integrate this force and put it at one point. Why we put it at 2/3 of here? Why we don't put it why we put this force at 2/3 from left? Why I don't? Can I put this force at like here at the end of the beam at the free? Why? Yeah.
Well, I mean,
If I put-
there might be an equivalent force, but its magnitude would have to be lower because it's farther.
You?
okay. I think it's at that point because like for one of two reasons. One, it could have just been randomly selected, and also that could just be like the center of I'm not sure how how to say, it's like center of like gravity or pressure, however you, it's like, whatever it's called.
Yeah, you are close.
It's one of those two reasons.
This should put the force, the equivalent force, in center of pressure. Otherwise, there is a moment. I can put equivalent of this here, but there should be a moment. I can put the equivalent of this force here, but there should be a moment. Center of pressure is a point if I squeeze a distributed force. At that point, there is no moment. What does this mean? This means that I take the moment from the left to here, from right to here, the moment cancel, only the force remain. It is the point of center of pressure. Center of CP. So, you see that CP is not the same as CG. Okay? It is not the same as CG. Center of gravity is due to the body. Okay? Center of gravity is due to the body. Center of pressure is due to the force. So, I compute pressure at center of gravity, but I put the force at center of pressure. So you can write what because I don't have enough space, you can write what I described for you. I want you to understand well, what does center of pressure mean? Center of pressure is a point where you apply all the forces equivalently, there is no moment. Yeah?
For the distributed load, can you give an example of what would cause that? It would be like a person standing on the edge of that beam.
No, it is like this pressure. It is a distributed load. You see, here has a less altitude, less pressure. As we move downward,
Okay.
so assume there are a little water here, no water here, a lot of water here.
Thank you.
So distributed load has, for example, in a static we can have some example in fluid. The example is like the dam. Okay. Any other question? Did you understand well center of gravity? Feature of my center of gravity, for example, is here. But my center of pressure depends on the pressure that air impose on my body. And then I need to integrate. Center of pressure need an integration. It comes from integration. I wrote you what is the center of pressure. For plane surfaces, center of pressure is given by these two relations. Let me write over the board. Center of pressure has two components, X and Y. X center of pressure, Y center of pressure. Why X and Y? Because this point, take a look, this point has an Y, take a look at my hand. This point has a Y and has a X. For example, if the axis is here. This point has a specific Y and a specific X. X of center of pressure is minus gamma sine theta, moment of inertia xy over P center of gravity area. Y of center of pressure minus gamma sine theta Ixx, moment of inertia of Xx, P center of gravity area. So here we are very close to static. I want you to understand well your static course. Okay? So these are Ixx is the area moment of inertia, Ixy is the product of inertia. I don't want you to compute the moment of inertia. I give you, you can have your exam will be open book. So you will have access to moment of inertia. So for different geometries, moment of inertia is given and the area is given by this. These are the most common geometries in fluid mechanics. Or dam here is a rectangle. Okay? The area is B multiplied by L. This is L. Take a look at my hand. This is L. B is perpendicular to the board. B is inside the board. Width. B is the width. Moment of inertia of xx is BL cubed over 12. Ixy is 0. If any geometry has a symmetrical configuration, Ixy is 0. Product of inertia is 0. So for this geometry, Ixy is 0. For this geometry, Ixy is 0. For this geometry, we have Ixy. For this one, we have Ixy because it is asymmetric. For this one, we have Ixy. For this one, we have Ixy. I will solve you two examples today. One with this geometry, one with this geometry. Okay? So, you should have this paper printed, put in near you when you solve an example, refer to this problem, compute the area, compute the Ixx, compute the Ixy. Okay? So these are all the story about plane surfaces. Yeah?
What is gamma in those equations?
Gamma is a specific gravity, rho g. So this one is a parabolic surface. This one is a parabolic surface. The parabolic surface, the area is 2 multiplied the big shoulder multiply a small shoulder divided by 3. And Ixx, Ixy are given by this. So you should have this paper with yourself. Now at the moment, the equation that I wrote for you here is for plane surface, like this one, not for curved surface. This is curved surface, curved surface, curved, curved. These two are plane surfaces. Okay? These two are plane surfaces. I solve an example for you for this one. I will give you a homework on this one. It's a triangle. Triangle is also a plane surface. Doesn't have a rounded edge. Okay, let's go to this example. Example 1. So we have a plane surface. You see a plane surface here. This is a wall. This is a plane surface with angle theta. This point is B. It is the hinge point. The point there is A. This is wall. This is gate. It is the gate of the dam. When you open the gate, the water goes out. It is a rectangular. Pay attention. The shape of this is important. Don't tell it is a rectangle. No, this is not important. The shape of the surface is important. The shape of the surface is a rectangle. This is 15 feet. This is 6 feet. This is 8 feet. Okay? And there are water here. The question asks us the force on the gate due to the seawater pressure. Force on the gate. I don't write the question, you can write it. Force on the gate. Force over the gate. Maybe I plot the gate with a different color. Okay? The force on the gate, the horizontal force exerted by the wall at A, force at point A, and the reaction at hinge B. Horizontal force at point A and forces at B. Forces on gate, points A, X in the X direction, point B, X and Y. These forces are requested from us. Do you understand well the question? The question is super simple. It is the simplest question that I could solve. Please help me in the solution. How much is the force on the gate? Pay attention. The shape of the gate shouldn't make you confused. We are not interested at this distribution. We want force at center of gravity. Okay? We should find pressure at center of gravity. So we need just 1 point of the gate. 1 point of the gate. Center of gravity. Can anyone tell me where is the center of gravity of this gate? It has a uniform mass distribution. Where is the center of gravity of this gate? Yeah?
Middle.
At the middle, yeah. So it is here. Okay. How much is the, so pressure F P is P center of gravity multiplied by A. P of center of gravity is gamma water. H center of gravity multiplied by A. How much is H of center of gravity? It is CG. I write the CG with a red point, red color. How much is the H of CG?
12.
Say again.
12.
What?
12.
12. Yeah. Why 12? Because it is middle of this. It is 6. Middle of this vertically. Middle of vertical is 3. 3 minus 15 is 12. Let me plot here. It is 9. It is 15. CG is 12. Where is the cleaner of the board? Anyone see the cleaner?
Oh, the eraser.
Yeah, eraser, yeah. Can anyone help me and go to the second floor and take an eraser from Jordan from the office? Can you please help me? Thank you. So, it is 9, it is 15. Okay? 9, 15, this is 12. Middle is 12. So, F pressure is super easy. Gamma water, in terms of, in British unit, gamma water is 64 pound force over feet cube. Okay? So this question is in the British unit. Don't multiply by 9,810. 9,810 is in SI unit. In British unit, gamma water is 64. Okay. So 64 multiplied by HCG 12 multiplied by area. How much is the area of the gate? The area of the gate, it is, okay. The depth is 5. The depth is 5. Take a look here. How much is this side? How much is this side? 10. From triangle relation, this is 10. So area is 10 multiplied by 5. Area of gate okay, 400 pound force. Create 400 pound force. This is the force on the gate. This is the force of the gate. Okay. So we solved the first part. Any question, any concern, any comment? Do you follow me? Any question from the last row? Maybe you have less access to the board. So, if I give you this question, you need to find center of gravity. Okay? The force, the pressure force is a function of center of gravity, altitude. Okay? So, if I make this problem complex, I tell you, for example, the gate has a non-uniform mass. So not the center of gravity is not at the middle. Maybe it is 1/3 from the B, 1/3 from A. So you should be very careful, okay? Center of gravity is important, not any other point. Center of gravity is important. And the area of the gate, you should know that the gate is perpendicular to this plate. So it has a width, the width or depth of the depth of 5, and this length is 10. So thank you very much. Thank you. So 10 multiplied 5 is 15. So good. Now the question doesn't end here. The question continues. Ask us forces at A and B. Okay? Forces at A and B. To now forces at A and B, we should know the center of pressure of the pressure force. Because we need, our problem is now a purely static problem. So this course, at this section, strongly need you understand well your static. Now this is a static problem. Take a look at me. It is our gate. This is point A. This is point B. And this is the center of pressure. I don't know center of pressure, so I assume here is center of pressure. Arbitrary, no worries. Be very careful. At A, the force can be horizontal and vertical because the question only asks us horizontal force at A. So at A, I plot this force, AX. At B, I plot BX. BY. At center of pressure, what is the direction of the water force at center of pressure? X or Y? I need to put this force, okay, at point center of pressure. At which direction should I put it? If anyone say correctly, send me an email and I will add a score to him or her. Yeah?
Is it facing into the gate?
Normal to gate. Okay, so send me an email. Okay, this is F P. Okay? Be very careful. The pressure force is normal to the surface. Not in X, not in Y. Normal to the surface. FP, normal to surface. What I require now before computing AX, BX, BY, what I require first, what I require. What is missing now? I find the force. What else I should find?
The location of it.
The location that the force work. Why the location is important? So I need to find CP. Why the CP is important for me? Take a look at statically, yeah?
You can then use the relationship between the forces and the moments.
Yeah, because we need to take moment, okay? I want to find forces. AX is missing, BX is missing, BY is missing. I have 3 missing forces. Take a look from a static point of view. When you have 3 missing force, you need 3 equations. Sigma Fx 0, sigma Fy 0, sigma moment around B is 0. Okay? So I need this arm of AX and I need arm of FP. Okay? For that I need center of pressure. It is a rectangle. As it is rectangle, I xy is 0, moment of inertia of product is 0. Moment of inertia of XX, Ixx, is BL cube over 12. B is the depth, L is the length. 5 multiplied 10 cube over 12. How much it is? It is 417 foot cube, foot force. Foot force. L. Okay. Take a look how I write. YCP. Y center of pressure. Y center of pressure. Can anyone read for me the equation on the board here on the bottom? Is minus gamma, what, sine theta,
Sine theta
multiplied by?
IXX over P center of gravity times A.
Very good. I can simplify this equation. Follow me. Minus gamma sine theta Ixx P center of gravity. What is P center of gravity? Gamma H center of gravity. Gamma H center of gravity multiplied by area. So the gamma cancel out. So this equation simplifies to, you can use this simplified equation, minus Ixx sine theta over HCG area. Okay? Minus Ixx sine theta over HCG area. Be very careful about theta. Take a look here. Please follow me. Theta is this angle. Theta is this angle or this angle. Okay? Theta is not this angle. This angle is not theta. The angle between the continuation of the gate and free surface is theta. Don't change theta, okay? Detect theta carefully. So, please reply me. Which angle is theta in this fictitious rectangle triangle? This is theta or this is theta? This is theta. This is theta. Okay? So theta, follow me. This is theta. This is theta. Theta, theta. So theta is the angle of the gate with horizontal direction. Okay? How much is sine theta from this triangle? How much is sine theta? 6 over 10. Sine theta, remember, is front angle over the inclined angle. Front over inclined. Cosine theta, what is cosine theta? Adjacent angle L to the inclined angle, okay? Inclined length, adjacent to the inclined. So, minus Ixx let me write here. How much is Ixx? I wrote here 417. How much is sine theta? 6/10. How much is HCG? 12. How much is area? 15. So it is equal 0.417 feet. Okay, so I should correct one thing here. Yeah, I should add one thing here. These locations are with respect to the center of gravity in the axes that are in these two directions. This is X, this is Y. So we shouldn't put the axis, clean the axis from here. We shouldn't put the axis here. The axes are here at center of gravity. The reference of the axis is at the center of gravity. Let me describe for you. Then I have y equal minus 417 feet. It is center of gravity, okay? Let me plot again here. It is center of gravity. It is center of gravity. It is center of pressure. This is Y center of pressure. No, not this is, no, not this one. This is X, this is Y. This is center of gravity.
Isn't the coordinate plane in the plane of the surface itself?
No, the coordinate is on the center of gravity. The coordinate,
I mean, shouldn't the xy be in the plane of the gate?
XY being the plate of the gate.
So if that's the gate, I'm just saying that the xy should be in the plane of the gate.
X in the plane of the gate. No, XY are, as you see here, it is in this direction, it is Y in this direction, okay? YCP is in this direction, and XCP is in this direction. So it is in, this is the axis, okay. This is Y, this is X. This is Y, this is X. It is a bit complex. It is Y and it is X. So, center of pressure, center of gravity. It has some Y deficit, okay, some Y deficit and some X deficit. So the X deficit is, this picture is better.
It just says down there that it's the plane view of arbitrary plane surface.
It is the plane surface.
Yeah, but the blue blob below it.
Yeah,
It says there that it's a plane view of the arbitrary surface, so we are.
yeah, but we consider this at the center of gravity. Center of gravity is here. Because here it is busy, it is very crowded, it plotted it here.
Yeah, I'm just saying that X should not stick out of the plane of the surface.
Out of the plane. Yeah, the X is the Y is in this direction and the plane, X in the opposite direction. Yeah, okay, yeah, you are right. They should be normal. And X also should be this way. Okay, it is not correct. Okay, yeah. It is a bit complex. Okay, so here, let's back to this 4.7. What does this mean? This means that between of I plot here it is our gate A, B, this is center of gravity, this is center of pressure. This distance is, I should put a minus here. I should put a minus here. Please put the minus for that, because there is a minus sign. Please put a minus here. Put a minus here, a minus here. This means that center of pressure is about minus 0.417 behind center of gravity. So this is 417. X of center of pressure is 0, IXY is 0, X of center of pressure is 0. So X of center of pressure is 0, so it means that center of pressure is on the same line as center of gravity. Take a look. This is X, let me plot X and Y. This is X, this is Y. Now you are clear. Yeah.
If the value of x was not 0, you would
If
be
it-
changing position on the face, right?
Go down or up. Yeah. So you have, if X is not 0, it is your plate, okay? It is your plate. If X is non-zero, or center of pressure is here. Not on the same gate.
How would center of pressure not be on the same gate, I thought?
If the gate has a distribution in this direction, it is not for the plane surface. It is not the case.
Is it possible that the x direction is indicating if you have your plane, if you look at the plane, then x is moving left and right on the plane while my y is moving up and down on the plane?
Yeah, yeah.
X is moving into and out of the page if you're...
No, it is Z. Out of the page is Z. We don't have, yeah, it is Z. Okay? But now, we don't take care of Z because because we consider 2D problem. Okay? If we consider 3D problem, if, for example, our gate is not just like this rectangle. Okay? Not this rectangle. It has, for example, this shape. This shape. So in that case, Z is important. But now Z is not important. So we just take care of X and Y. Okay? We just take care 2D problem. It is 2D problem, not 3D problem. If we consider 3D problem, I should derive for u z of center of pressure. But now we don't take care of 3D problem. Yeah?
The question I'm asking is, isn't the second dimension in this problem the width of the?
No, the second is not width. It's not width. We are not in plane. We don't go in plane. We are on the surface. Okay? We are on the surface. You see? X is going down in the normal to the surface, down or up. Okay? For example, center of pressure can be here in the water, can be here in the air. Y is in the gate location. We are not in 3D.
Thank you.
Thank you. So, take a look again here. Let me clean this one. We are here. Y, this equation, YCP, how much on the gate we are down or up? We are here, down of the gate. And XCP, how much down, how much in the out of the plate we have the center of pressure. We don't have center of pressure there. Okay, so we have this one. Let's back here to this graph. It is our free body diagram. It is our free body diagram. It is center of gravity. This is 0.417. So question, if YCP is plus 0.417, where will be the CP? If it was plus 417. Yeah?
Be closer to A.
Say again.
Be closer to A.
No, if it was plus, it is now it is minus, it is here. If it was plus, where it?
Right, would it be closer to A?
Yeah, where it is here. Yeah, it will be here. So usually YCP is lower than center of gravity. Lower than center of gravity. So let's back to this static problem. What is missing at CG? We ignore pay attention, we ignore the weight of the gate compared to other forces. Okay? If we didn't ignore weight of the gate, which force I should plot here in addition to these forces? Yeah? Gravity. And gravity is in the y direction. Okay? We ignore the weight of the gate. Weight of the gate is smaller than the forces, the other static forces. So it is all free body diagram. It is in better shape here, or free body diagram. At A, we have AX. Your book showed AX by P. At B, we have BX, BZ, or BZ, it's showed by BZ, direction of BZ. At this point, we have F pressure. So I don't want to clean the board, but I need to clean here. Let me take a photo and then clean here to write the moment equation. Okay, I clean here. So, sigma m at B is 0. how much is the moment of AX? How much is the arm of AX around point B? How much is the arm of point A? Yeah? Yeah?
6.
6. Very good. How much is the arm of point pressure, of force point pressure around B? How much is the moment? This length. Okay? So when you are going to compute moment, you need vertical distance between the force and the point you take the moment. Agree? So I want sigma m around B. I don't say A multiplied by L by length of the gate. No. A multiplied by 6. AX multiplied by 6. I should take the same direction, positive or negative. The moment from AX around B is counterclockwise. Okay? It is counterclockwise. I take counterclockwise positive. Okay? Counterclockwise positive. FP multiplied by this length, I call it LP. This moment, positive, clockwise or counterclockwise? The last one. You? Yeah.
Clockwise?
Clockwise. Positive or negative?
Negative.
Negative, very good. Minus FP multiply LP. How much it is equal? This is equal 0. Pay attention. I should be very careful around which point I take the moment. Okay? If I take the moment around point A, not good. Why not good to take moment around point A? Why? You?
There's too many unknowns.
Yeah, because we have 2 unknowns, 1 noun, and when I take moment around this point, 2 unknown contribute. So I cannot solve. Now I can solve for AX. FP is given, FP is given, it is FP. LP, take a look here. This is 10. Question, why the gate length is 10? How I can, in the figure there is no, the 10 is not given in the question. Yeah?
A squared plus B squared plus C squared.
Exactly. 8 squared plus 6 squared is 10. It is the length of the gate. Okay, where is the center of gravity of this 10? Here. How much it is? 5. LP is 5 minus 0.417. Okay? LP is equal 5 minus 0.417. So, AX multiplied by 6 is equal 38,400 multiply by 5 minus 0.417. So AX is found as 23 900 LBF. Okay. Any question? Any comment? Are you okay with this? The key point is to find the point that pressure force act on the plate. On the plate, it acts at YCP, XCP. XCP is usually 0 if it is a rectangle, but if it is a triangle, maybe not 0. Yeah, because IXY of triangle is not non-zero. But AXX is, AXY is 0 for rectangle. Now we need to find BX and BY. For BX and BY, we write the balance equation, sigma. I wrote the moment equation here, okay? Now I write the force equation. In static, sigma Fx is 0, sigma Fy is 0. So I clean here. Sigma Fx is 0. So, take a look at the free body diagram. Minus Ax plus Bx. Fp, this is, take a look here, this is theta. This is theta. Plus Fp sine theta is 0. Am I correct? Fp sine theta? Yeah, Fp sine theta. Are you good with this equation? This balance equation? Ax, why I put Ax minus? Because it is on the negative direction. Bx plus, it is in the positive direction. If, yeah?
AX is supposed to be 29,300. I did the calculation again.
Here it is at 23,900.
On the lower-
Oh yeah, you are. Thank you. You see the board make a mistake. Thank you. So please, if you can correct this one, it is right. Here it is correct. Yeah, thank you. So you see, sometimes the book also make a mistake. So, okay, we have Ax equal this value minus 29,300 plus Bx plus Fp, which is 38,400 multiply sine theta. Sine theta is 6 over 10. 6 over 10 is 0. So Bx is found. How much is Bx? 6,300. 6,300 feet. LB feet. LBF. Okay, let's go to BY. Take a look at the free body diagram. What equation should I write to obtain BY? What equation should I write? Yeah? You?
The
No, which equation? First, below it.
summation of y, forces in the y,
Sigma is equal what?
0.
0. Very good. Sigma F y is 0. So every time, try to write the basic equation. So you see I star, sigma m b 0, moment 0. Sigma f x 0, then I write. Sigma f y. Which forces are in the y direction? So, or z. It's better to say z, sorry. Because I take z. Pay attention, we have two coordinates here. One coordinate global coordinate, one coordinate for local, for the gate, for the center of pressure. So sigma fc is equal bz positive minus or plus fp cosine theta or minus fp cosine theta equals 0. Am I correct? Bz minus fp cosine theta is equal 0. So Bz is equal 3,400 multiplied by 8/10 is equal 30,700 LBF. This is Bz. Okay? So, we are reaching to the end of this session. I taught you the plane surface. I solved an example of the plane surface. On Thursday, I will work on the curved surface. And I try to finish this chapter by curve. You see, every topic that I teach, I solve a detailed example. And I try to give you the homework 3 today. And just be careful, follow this strategy for your other problems. Thank you.
So I have the average score for the first attempt and then they just.
The average of them?
Yes.
Yeah, I assume the due dates were gonna be the week after they got signed, but they're like a week
When I
due dates.
transfer
So I'm probably gonna start it, I'm hopefully gonna start it today at some point, so I don't do it all tomorrow, but see what,
when I transfer this to Canvas, same and receive a spin Canvas on that one. Same I will
probably
update
you got them all
But
at,
now it's not just
yeah, see in a little bit, a few hours.
Okay, you can call me. You can see me.
Oh, I'm fantastic. Where are you going? Oh, nice.
Yeah, this is no, this is not. Yeah, this is fine.
I guess you got snowed in, so we didn't have
Oh, shit. Good luck.
You